The quadratic formula is used to solve quadratic equations when you can't factor them, or maybe you're someone who doesn't enjoy factoring, and so then the quadratic formula becomes a formula that will work every time. To use the quadratic formula, you must be set equal to 0, and you must be in this form so that your x squared term is first, then your x term, and then your constant. Once you are in this form and in this order, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This value under the square root house, the b squared minus 4ac, is called the discriminant. The discriminant tells you the type of solutions that you're going to have. That value, the discriminant value, is also what differentiates each problem from being worked one way versus another way in the simplification process. All right, let's start with this first example. In the first example, we can see that it's in the correct form, the squared, the x, and the constant, and it's set equal to 0. If you'd like to, you could come out here and say, okay, a, that's an understood 1, a is equal to 1, b is equal to negative 5, and c is equal to negative 7. Then we're going to plug it into our formula. So that says x equals negative b, which is negative 5, plus or minus the square root of b, which is negative 5 squared, minus 4 times 1 times c, or negative 7, all over 2 times your a value. So when I simplify or clean this up, negative of a negative is obviously a positive 5 plus or minus. Now write down the square root, but then go to your calculator and type that in. It just saves time and it avoids careful mistakes. So go to your calculator, type that in perfectly like you see it, making sure that you use parenthesis buttons around the b squared. Always use your parentheses there. So when I type that in the calculator, I'm going to get 53 all over 2. Now, that discriminant, or 53, cannot be simplified. That's not a radical that we can do anything to, so we are done in this case. Now, occasionally teachers will like your answer as a decimal. Perhaps if it's a word problem and you're trying to solve for how many seconds it takes an object to fall off a building and hit the ground or something like that. If that's the case, if they do want it as a decimal, simply do the plus and the minus. We'll do the positive of it and we'll do the negative. So we would say 5 plus the square root of 53 all over 2. And we would say 5 minus the square root of 53 all over 2. So I would go to my calculator and say 5 plus the square root of 53, hit equals, and get 12.28 divided by 2 and get 6.14. Then I would say 5 minus the square root of 53, hit equals, and get negative 2.28 divided by 2, and you get negative 1.14. Again, some teachers like the decimal, so you'll know just in case you have to do that. Let's take a look at the second example. I can see on this second example, I'm also already set equal to 0, and I'm in decreasing order. So I could go through and say that A is equal to 2, B is equal to 5, and C is negative 7 again. So here's your formula over here. So here we go. X equals negative B, which is 5, plus or minus the square root of b, which is 5 squared, minus 4 times a, which is 2, times c, which is negative 7, all over 2 times a, or 2 times 2. Okay, so I'm going to have negative 5 plus or minus. Now, draw the square root, but then go to your calculator and type that in perfectly like you see it to see what value is under the square root. In this particular case, I'm going to get 81 all over 4. Now, 81 is a perfect square. So therefore, I need to simplify this. The square root of 81 is 9. So that means I have negative 5 plus or minus 9 all over 4. This must be simplified because all of these are like terms. So let's break it to the positive side and let's break it to the subtract side. So negative 5 plus 9 over 4, which is going to give me 4 over 4 or 1. And then I'll do the subtraction part. I'll say negative 5 minus 9 over 4. And negative 5 minus 9 is going to be negative 14 over 4, which reduces to negative 7 halves. You always want to reduce your fractions. Let's take a look at example 3. Looking at example 3, I see, first of all, I'm not in the correct form. I need to be set equal to 0. So subtract your x from both sides. When you do that, you will get 0 over here, but make sure that you have this in the correct order. So it's 3x squared, then the minus x, and plus 2. Pick out your A, your B, and your C, making sure that you keep your signs with your letters. Now, if you'd like to try to put this in the quadratic formula and then check back with me, pause the video and see how you do. So to solve this, I will say negative b, which is negative 1, plus or minus the square root of b negative 1 squared, and we talked about how important it is to make sure you have parentheses there, minus 4 times a, which is 3, times c, which is 2, all over 2 times 3. All right, negative of a negative, those two negatives make a positive, plus or minus, draw the square root house. Go see what lives under that square root house. So go to your calculator, type that in, and when you do, you're going to get negative 23 all over 6. Now, negative 23 is the value of the discriminant this time. You're not allowed to have negatives under square roots. When you do, you get imaginary numbers. So you must pull out your imaginary unit. So therefore, I'll have 1 plus or minus, pull out your I, that takes care of the negative under the house. Then you have 23 all over 6. If I could simplify the square root of 23, I would, but I can't, so we are done. All right, look at example 4. Okay, the first thing I hope you notice on example 4 is that you're not set equal to 0. So let's do that first. Add your 21 over so that you have 2x squared minus 12x plus 21 is equal to 0. All right, pick out your A, B, and C and put it into the quadratic formula. And if you want, pause the video and come back and check to see how you did. All right, hopefully you said A is 2, B is negative 12, and C is positive 21. To solve it for x, we'll say negative of a negative 12 plus or minus the square root of b, which is negative 12 in parentheses squared, minus 4 times a times c all over 2 times your a value. Okay, again, 2 wrongs make a right, but only in math class where those 2 negatives make a positive. So 12 plus or minus, draw your square root, go to your calculator and see what's the value of your discriminant this time. And when you do, you're going to see that you get a negative 24 under the square root house, all over 4. Now, we see again that we have the imaginary unit. Your discriminant is negative, so that means you have imaginary roots. So we need to pull our I out for the imaginary. And if you have trouble with some of the imaginary things, you can look on my channel and find a video about the imaginary complex numbers. Not only will we pull the I out, but then there's a 24. And that's a radical that can be broken down. We can simplify that radical. And again, if you want more details on simplifying radicals, be sure to go check out that video. So I have 12 plus or minus, and I'm going to pull out the I first over 4. Now, you might could do this step together, but I'm going to break it into parts in case people need to see that. So 12 plus or minus. Now, let's take a look at that 24. To break down the 24, you're looking for perfect squares that go in there. Well, pretty quickly you can see that that's 6 times 4 is 24. The square root of 4 is a perfect 2, and then just drop down, your square root is 6. So that'll be 2i on the square root of 6 over 4. But we're still not done yet because we can reduce. We can actually reduce this. If there is a number that goes into this, this, and this, you must reduce. Not the square root, that's a different type of number. But 12, 2, and 4 all have a 2 that will go into them. So I'm going to say 2 into itself once, 2 into there twice, and 2 into there 6 times. You have to be in all 3 or you can't do it. So 6 plus or minus 1i, square root of 6 over 2. The 1i is optional. You could just say I if you want to. Okay, took a look at number 5. Again, if you want to try, pause the video and then come back and check your answer with me. The first thing you decided is it's not set equal to 0. So we need to plus 6x plus 6x. We need to subtract 23, subtract 23. That gives us 0 on this side. Over here, put that in the right form. None of those are like terms, so I would not force them together. And I'm going to keep each sign with each person. So my A value is 1. That's an understood 1. B is 6. And C is negative 23. Okay, using your formula, and I keep writing that over here until you get it memorized. You might have to look at it. So x equals negative b plus or minus the square root of b in parentheses squared minus 4 times a times c all over 2 times a. So I have negative 6 plus or minus, let's draw the square root house. Let's go to our calculator to see what the discriminant is or what's underneath that square root house. And so when I do that and I multiply that together, I'm going to get 128 this time, all over 2. Now, that is a radical that can be simplified. I need to break that down. So again, what I want to do is I'm taking that 128 And I'm trying to think, what's a perfect square that goes into 128? So it's 64 times 2. I used 64 because the square root of 64 is perfect 8. So that cancels to just an 8, and you bring down your radical 2. So I'm going to get negative 6 plus or minus 8 square root of 2 over 2. Here is another situation where there is a number that goes into all of those. So we need to reduce, simplify. It's like simplifying or reducing a fraction is what it is. So 2 goes in there once, 2 goes in there 3 times, 2 goes in there 4 times. Remember, we said we're not touching that. That's under the square root. That's a different type of number. But this is just like having 6 over 2 and 8 over 2, and you're reducing the fraction, just kind of in a shortcut because it's in all three. So I get negative 3 plus or minus 4 square root of 2 over 1. But if you don't want to write the 1, you can do that. Let's take a look at example 6. Again, we're not set equal to 0, so that's the first thing. So subtract 29x, subtract 29x, add 35, add 35. So I have it set equal to 0, write it in the correct order, 6x squared minus 29x plus 35. If you'd like, pause the video and try this and then come back and check. Your A value is 6, your B value is negative 29, and your C value is 35. These numbers are looking kind of large. So x equals negative of a negative 29 plus or minus the square root of negative 29 squared minus 4 times your A times your C, all over 2 times A. Well, there's two negatives that we know turn into a positive. Plus or minus, draw the square root, but then go to your calculator, type that in exactly as you see it so we can see what our discriminant is equal to. And this particular time when I put that in, I get 1. It all just comes out to a 1, all over 12. Now, 1 is a perfect square. Sometimes students forget about that. That's just 1. The square root of 1 is 1 because 1 times 1 is 1. So I get plus or minus 1 over 12. Now, these are like terms, so I must simplify to this positive and the subtraction. So on the positive side, I'll say 29 plus 1 over 12, which is 30 over 12, which I always reduce to 5/2 in this case. And then the subtraction says 29 take away 1 over 12, which is 28 over 12, and that of course reduces to 7/3. All right, last one. Okay, if you want to pause the video and try this, do your very, very best. So first of all, we got to set it equal to 0. Now, when I set this equal to 0 and subtract that x term over, notice that it goes in the middle. 4x squared minus 4x plus 17. Pick out your A, your B, and your C. And then to solve it for x, we get negative of a negative 4 plus or minus the square root of negative 4 squared minus 4 times A times C, all over 2 times A. Okay, those two wrongs make a right, but only in math class. And then draw your square root. Let's see who lives under the house. Let's see who our discriminant is now. So when I put that in the calculator perfectly, I get negative 256 all over 8. Now, because of the negative, I know that I'm going to have imaginary. So I'm going to pull out the imaginary unit, or the I. And then also, and you might not think about this, but that happens to be a perfect square. So you might want to check on your calculator as you work one of these problems, especially if it's a large number, because you might not be sure. So I'll have 4 plus or minus, pull out your I, and then the square root of 256. If you go to your calculator and say square root of 256, you will get 16. So 4 plus or minus 16i over 8. And lastly, I can see that this will reduce. There is a 4 in there one time, a 4 in there 4 times, and a 4 in there 2 times. So your final simplified reduced answer is 1 plus or minus 4i over 2. And that's your final answer. I do want to note that you cannot cancel that 2 and that 4 because it's got to be in all 3 in order to cancel. If you need more help or practice on the quadratic formula, watch my teaching video on this topic. There you can watch me work more examples. See you next time.